There are two main statistics you can use with qualitative data. It's mode and proportion. Mode is a simple thing. It's just a value with biggest frequency. If you have several categories and you have a category with the biggest frequency, with the largest frequency, that's the mode. Okay. And the proportion, you already know it. It's a ratio of the values that belong to a particular group, that belong to a particular level of the categorical variable, and the total number of values. So we discussed proportions already in the second block. Here I'm going to refresh this knowledge and also show you a little bit more how to make, for example, tests for proportions. And by using proportions, we will be able to answer these two questions. Do most of the engineers know R? And then do most of the engineers have salary higher than the average? Okay. So this is the statistics that we have used before. These are frequency tables, and we already know that actually the relative frequencies corresponds to the proportions. That's what we see here. Okay, so the proportion for engineers who don't know R is a 60%, and proportion of the engineers who know R, it's a 40%. Okay, and then in this case we can also calculate mode, and mode in this case will be a category N, meaning that that's the category with the biggest amount of values. Then we can do the same for the salaries. So in this case, mode will be average because that's the largest frequency we have in the table. And then we have the proportions for the low, the average, and the high frequency correspondingly 24, 48, and 28%. And you remember that that's the values only for 50 engineers. We cannot tell anything about the whole country by just taking these values. We need to make an inference. And I'll just recall you that proportion for the population we will call pi, and then the proportion for a sample, it's a p hat. Okay, so it's just not to confuse you with the p values. Okay, so the idea is, can we get pi by knowledge by knowing p hat? And probably if we know pi, can we calculate a p value to get a p hat as extreme as we have or even more extreme? So let's discuss this proportion. So we know that if we know a proportion for a sample p hat, then we can calculate confidence interval, possible values for the proportion of the population, and we can also calculate a test, a p-value for this several null hypothesis. If the proportion for population is equal to a particular value, at least equal to the particular value, and does not exceed the particular value. Okay. And then we already know that if we use the idea of sampling distribution, if we take a lot of samples from the same population, calculate proportion for the samples, and look at the distribution, we know that the distribution is normal. Okay, so the proportions are normally distributed. And you can calculate the average and standard deviation. Average in this case will be a proportion for population, and the standard deviation will be calculated like this, using the proportion for the population. Okay. How to make an inference if we don't know proportion for a population, but we know proportion for a sample? If your sample is large enough, meaning that you have at least 10 values inside the level and outside the level. For example, if we are talking about engineers, we have at least 10 values for the small salary and the salary that is not small. Okay, so if we are talking about proportion for the small salary. If this requirements is met, then we can use a point estimate. So it means that instead of pi, we can just calculate the parameters of normal distribution using proportion of a sample. So we just need to know a proportion for a sample, and we need to know a sample size. Of course, it works as usual. It works only if your sample is random and representative. If you have any problem with taking your sample, these statistics will not give you the truth. Okay. So it makes the calculation of proportions, confidence intervals for proportions very easy. You just use error margin, which is z times standard deviation for your proportion, standard error for your proportion. And z, it's how many standard deviations you should go in normal distribution for a given significance, right? So for example, if significance level is 95%, if you want to calculate 95% confidence interval, then z is 196. Again, you know that if it's 95.5, z is 2, and so on. And you can always find z by using ICDF function for normal distribution. So that's how to do it. We already done this several times in the previous blog, but I'm just going to repeat it just to make it, just to rephrase this. Okay. So these are the questions. What is 95% confidence interval for proportion of engineers who know R? Well, we know that first of all, we need to calculate the standard deviation for standard error for proportions. So the standard error for proportions is the proportion of a sample, then how many we have outside this, and then divided to n, right? So how many engineers who know R? In our case, it's 40%, so we need to calculate it like 0.4 times 0.6, and then divide it to 50, which gives us 0.24 divided to 50, which is approximately 0.07. I just use 2 in this case just to make it a little bit easier. Then we know that for 95% we need to take 1/96 of this.
Case pi,
so the error margin is our proportion
will be
plus minus
196
the error margin,
196,
which gives us 0.4, which is again plus minus 0.14. So the 95% confidence interval is the following. It will be 0.36 and then 0.54. Okay. So the true amount, the true proportion for engineers who know R is between the 36 and 54%. So we have a hope that at least half of engineers in Denmark know R. Okay. Then we can do the same for 99% for the proportion of the engineers who have high salary. We know that the high salary, this proportion for high salary is this one. So we can also calculate the standard error first, which will be 0.28 times 0.72 divided to 50, which is approximately, I will just use calculator to get the value. It's approximately 0.06. Then again we calculate the error margin to get exactly 99%. We can use ICDF for that. 2.58 standard errors. So it will be equal to 2.58 times 0.06, which is again approximately 0.15. So we can calculate the proportion. So pi will be equal to our proportion plus minus error margin, which gives us 0.28 plus minus 0.15. which gives us the confidence interval of, if we take the minus, it will be 0.13, 53. So that's the proportion of engineers in population that have a high salary. So it's between 13 and 43%.